time. What? Homework time, yeah! All right, here we go. Lesson 20, homework. Let's dig in. Start, of course, as always, by jotting our name down at the top. So when you hand in your work, you are sure to receive credit for having done your awesome homework. I'll put my name, you put yours, and for the date, I will write today, and you write the actual date, where and when you are. Let's read us some instructions, shall we? Number 1, Maria solved a division problem by drawing an area model. Nice job, Maria. So look at the area model. There it is. What division problem did Maria solve? Okay, so this is the exact same thing as the multiplication area models. There's no difference here. It's the same model. It's just how are you thinking about it that's different. So this in here, I'm going to trace over Maria's area model here. This all the way around here, that is the product of this factor and this factor. And notice I'm saying this together, this factor. Okay, so she has 30 is 3 times 10, and 24 is 3 times 8. So notice I traced the full outline there. So how many square units are there inside there? I'm going around and around and around and around. Yeah, 54. So 54 is the number she started with because this is division. She didn't start with the 2 factors. She started with 1 factor here and the square units, the product. And so that's how we work division, the inverse of multiplication. So 54, and she was dividing it by, right here, 3. And now when you say, well, what was the quotient? You have to be careful. You can't say it's 3 times 10 or 3 times 8. No, it's 3 times 10 plus 8, 10 and 8 together, which of course is 18. And so stop and look. Does that make sense? 3 times 18 is 54. 54 divided by 3 is 18. And we could even say 54 divided by 18 is 3. Yes, very good. So this is the division problem she was solving. And so now, very simple to do this out as a number bond to represent Maria's area model. Start with the total, which is the 54. Then show how the total is split into 2 parts, just as it's done here, 30 and 24. Below the 2 parts, meaning right here in this division of an addition equation, represent the total length using the distributive property and then solve. Okay, well, let's go through this step by step. So it tells us very simply, start with the total. So that is the 54. And then we could see, we said, okay, we're dividing by 3. So how many tens of 3s are there in 54? So when you look at it, you say, okay, can we do 10 times 30? Yeah, that's 30. Can we do 20 times 30? No, that's 60. That's over. So that's, did I say times 30? If I did, it was supposed to be 10 times 3. Yes, that's 30. Can we do 20 times 3? No, that's 60. It's too much. So 30, that's where this 30 comes from. We didn't just randomly select this number. And then we say, well, what does that leave out of the 54? It leaves 24. Because that kind of subtraction, you're at the point now where you could do that in your head, or if you have to write it out, do so. And so what we did here, using the distributive property, was we took the 54 and we said, well, let's think of it as 30 divided by 3 and together with 24 divided by 3. That's the distributive property. It means we can think of 54 as 30 plus 24. And what do we actually get here? Well, we already know from the area model, we get 10, right? And we get 8 over here. 24 divided by 3 is 8. And 10 and 8, of course, are 18. So this is how the whole area model of division thing works. If you understand that, you are golden, good to go. So let's go on to number 2. Okay, and number 2, we're doing the same thing we did back in number 1, except now, no help from Maria. Thanks a lot, Maria. Okay, we'll do it ourselves. Fine. Good friend you turned out to be. Solve 42 divided by 3 using an area model. with no help from Maria. Draw a number bond, okay, just like we did in number 1, and use the distributive property to solve for the unknown length, which we also did in number 1. That was all the equations at the bottom there. Okay, so our area model is simply a rectangle. It does not have to be in any particular proportions, just a rectangle will do. All right, we know our divisor is 3, so we'll use that to represent the length. Our area is 42. Right? This whole thing here is 42. So the question is 3 times what is 42, which we can also state as 42 divided by 3, just as we have here. Now when we think about it, when we look at 42, we say, okay, we can do 3 times 10 is 30. If we do 3 times 20, then we're up to 60. That's above the 42. So when we go to divvy this up, to partition it, we say, look, of that 42, we can say, hey, we can split it into 30 plus 12. Now, where did I get that from? I said, well, how many tens of 3s are there in 42? So, can I do 10 3s? Yes, that's 30. Can I do 20 3s? No, that's too much. It's 60. And if it weren't too much, I could even keep going and say, can I do 30 3s? 30 times 3? Is it, if I were dividing, say, 92 by 3, I could say, okay, so I could do 90 and 2. You see how that works? That's where this 30 and 12 come from. We don't just magically make up these numbers. That's the logic behind it. So 3 times what is 30, also known as 30 divided by 3, is, yes, we just said it, it's 10. 3 times what is 12, also known as 12 divided by 3, is, yes, 4. Okay, and so let's just write this out, that what we did here was we said 42 divided by 3 is, well, there it is, 10 plus 4 is 14. All right, and let's even do a little check here. Let's do it over here, just to make sure we are not lost our little heads here. Let's do a little check. 3 times 4 is 12. Regroup that 1. 3 times 1 is 3. Plus 1 is 4. Okay, 42. It checks out. Now let's draw the number bond. What we did was we took the 42 and we partitioned it out, saying, well, because I'm dividing by 3, again, I just pull these numbers out of a hat. I'm dividing by 3, well, 30 works with this. If the number weren't 42, if it were 62, then this would be 60 and 2. You see how that works? All right, so, and that left 12. And now to use our distributive property to solve for the unknown length, what we did here was we took this 42 divided by 3 and we said, hey, let's think of it as 30 divided by 3. And I'll put that in parentheses because I need to do that first. And then add that to, also in parentheses, 12 divided by 3. So what I did was I distributed, that's why it's called the distributive property. I distributed, or kind of cut up or handed out, you can think of the 42 as 30 and 12 to make the division doable and easier. So 30 divided by 3, we already know, we just did it, is 10. And 12 divided by 3, we already know, we just did it, is 4. And so that's where we got the quotient of 14. Beautiful, and we already did a check. We are golden. Shing, moving on. Well, hello there, number 3. How you doing? All right, well, look, it's kind of more of the same, but with a slight tweak to it. So here we're going to solve 60 divided by 4 using an area model. Okay, just as we've done. Draw a number bond to show how you partition the area, which we've done, and represent the division with a written method, which means we could use any written method that we have in our toolkit of written methods to represent that division. So let's jump in with the area model. So we draw ourselves a rectangle to start with. That's what we're using for these area models. And we know our divisor is 4. We'll put that as the length. to keep things, we could put it elsewhere, right? We could put it as the width, but this makes sense. This works. And now with the 60, again, we don't pull these partitioning numbers out of our socks. We stop and say, okay, how many tens of 4s are there in 60? Well, I could do 40. Can I go to 80, 120, 160, 200? No, 40 is as high as I can go because my number is 60. So when I partition here, or section off this area, that's where this 40 comes from. Say, how many tens of 4s are there? Are there 10 4s, 20 4s, 30 4s? I want to work with those even tens. It makes life easy. And that leaves what out of the 60? It leaves 20. Beauteous. So 40 divided by 4 is, also known as 4 times what is 40? 10. Yes, indeedy do. That's what we already said. And 20 divided by 4, also known as 4 times what is 20? That's right, 5. Now these are coming out nice and even so far without any remainders, but obviously things are going to be a little different once we get to that. Okay, so now when we draw our number bond, what we started with was 60. And we partitioned it as what? Well, 40, because there were 10 4s and 60. We're looking at how many tens of 4s. And that left 20. That's how we got those numbers. It's important you understand where those numbers come from. We're going to just make it up. And so let's use the distributive property first. So what we did here was we said, okay, what's 40 divided by 4? Because remember, our divisor is 4 back from the beginning here. And then we'll combine that, or add it to, the quotient of 20 divided by 4. Beauteous. Okay, so what is 40 divided by 4? Yes, we already did it. It's 10. And we'll add that to the quotient of 20 divided by 4, which, yes, we already know is 5. And so our supreme final quotient, of course, is 15. 10 and 5 make 15. And to do this out as regular old division, if you write, and by that I mean standard algorithm, 60 divided by 4, you say, how many 4s in 6? 4, 8, 12, no, I can only, 4, there's just 1. Okay, there's 1 4 and 6, because 1 times 4 is 4. I've handed out those 4 10-packs of donuts, if you remember our way of thinking of this from before. That's why I'm subtracting it. So 6 minus 4 leaves 2 10-packs of donuts, which I need to open up those boxes now, combine them with the 0 loose donuts I have hanging around. So I have 20 donuts now to hand out to 4 people. How many will they get each? Well, there are how many 4s in 20? 4, 8, 12, 16, 20. So there are 5 4s in 20, because 5 times 4 indeed is 20. And we hand out those loose donuts and we are left with no donuts. So this is another way of representing it. And of course it doesn't say we have to, but hey, we are overachievers, so we're going to check it. That 15 times 4, and we had no remainder, should be 60. 4 times 5 is, yep, we already know, 20. Regroup that too. 4 times 1 is 4. Cross it out. Plus 2 is 6. It checks out to be the 60 we started with. Look at that. You're a pro, man. Let's go on. And would you believe in number 4, it's kind of more the same again with a slight difference. We are to solve 72 divided by 4 using an area model, and then explain, so there's a little difference, using words, pictures, or numbers, the connection of the distributive property to the area model. Okay, let's do the first things first there. Solve 72 divided by 4 using an area model. So again, just draw ourselves a sweet little rectangle. My, that's a fine looking rectangle, ain't it? And we know our divisor is 4. Put that over here as our length. Now, our area here is 72, but we're going to ask ourselves, and this is just my way of putting it, how many tens of 4s in 72? So we'd say, okay, well, 10 4s is 40. Can we go to 20 4s? 20 4s? 20 sets of 4s. Yeah, well, that would be 80. That's too much. Okay, so 40 is what we can do. That's where we get this number from, because we're looking for our easy tens. That's the idea, is you're looking for your easy tens. And that would leave what from 72? In other words, 72 minus 40 is, right, 32. Okay. So that's where those numbers come from. If this number had been 92, we would have said 40, 80. This would have been 80. And if it were 92, it would be 80 and 12. You see how it works? We're looking for our easy tens. How many tens of 4s in 72? Well, now the division's easy to do. 40 divided by 4. We've already done this. We know it's 10. 32 divided by 4. Well, it's asking 4 times what is 32? And assuming you know your multiplication facts, yes, indeed, you do. That is 8. There we go. So let's just write our full answer here, just to have it written down. That 72 divided by 4 indeed is 18. And now we want to explain the connection of the distributive property to the area model. Well, let's actually do out the distributive property here. So a good way to start is with that number bond. That we started with 72, and what we partitioned it into? Yes, 40 and 32. Yeah. And so with the distributive property, what we said was, hey, 40 divided by 4 together with 32 divided by 4, that's going to give us the quotient of 72 divided by 4. It's just a way of breaking it down, partitioning it out, so you can actually accomplish the division. Because if I could just say, like, hey, what's 72 divided by 4? And you'd be like, 18. If we could do that, well then, hey, we wouldn't have to do any of this mess. But we got to do this mess because when I say 72 divided by 4, you say, huh? And I say, huh? And your mama says, huh? Everybody says, huh? We don't know right off. We have to find a way of solving it. And that's what this is all about. Okay, so we already said we know that this is 10 and 8, which of course equals 18. Beauteous. So now what is the connection of the distributive property to the area model? Well, I think we've demonstrated that with numbers, haven't we? Because it said explain using words, pictures, or numbers. And so we did it with pictures. The number bond is a sort of picture. And with numbers by showing the distributive property here. If we wanted to, we could do one last thing here. We could say, hey, this is that. And this is that. That those arrows say we just want to make that actual connection between the area model and the distributive property. Like there it is. There's the connection. Good enough for me. Makes sense to me. All right, let's look at number 5, shall we? Yes, we shall. And boy, can you believe they saved kind of the easiest one for last here, because in this one, we'll solve 96 divided by 6, okay, using an area model and the standard algorithm, which we had already done earlier just for fun. So here we go. Let's draw our area model. Again, just draw a rectangle. The exact proportions don't really matter. It's just a loose representation. Our divisor of 6, we know will put us the length. And now 96 is this whole area, but we need to partition it so we can actually solve the division. We say how many, and this is a way of thinking about it, how many tens of 6s? Well, skip count by tens of 6s, in other words, skip count by 60s. 60, 120, 180, 240. All right, 60 is as high as we can go, right? Because as soon as we hit 120, we're over that 96. So 60 is one partition here. And from the 96, that leaves what? So 96 minus 60, 36, which you probably recognize right away, rather, as something that's evenly divisible by 6. So let's do that division. 60 divided by 6, yeah, we already know it's 10. That's why we did it. And 36 divided by 6, well, you know your facts. 6 times 6 is 36. So there we go. And so we can just state here, it's always good to state your answer, that yes, indeed, 96 divided by 6 is 10 and 6, right? 16. And now using the standard algorithm, and this is the goal. Look, neither the Eureka mathematicians nor I, nor your mama, nor Jesus want you doing area models for division when you're 22. The whole point is to learn the standard algorithm. The area model is to show you this is how division works, so you understand what you're doing. You're not just blindly following steps. So here we go. This is the goal here, the standard algorithm, the usual way of doing things, figuring it out. So 96 divided by 6. How many 6s in 9? 6, 12, 8, oh, okay, yeah, just 6, right? When we skip count. 6, we can't go to 12. So there is 1 6 in 9, because 1 times 6 is 6. We subtract, and we get 3. We combine that with the 6 1s we have, because that 3 is in the tens place. Its actual value is 30, although we're speaking of it as the digit 3. So we have 36 now divided by 6. Well, there are 6 6s in 36, we already know, because 6 times 6, yes, indeed, is 36. And when we subtract, we have no donuts left. And so there we are. There's the area model, there's a standard algorithm, and you, my little friend, are all done with homework time. So I'll see you next time. It is, once again, homework time.